Hi everyone, and welcome to our very first video here. In this sort of series, we are going to be doing a bit more whiteboarding, just due to some demand around can you draw things and can you explain things. So over the last few months, I've been working quite extensively with a lot of security-focused people, but also business-focused leaders, and a lot of these sort of videos are inspiration from those sessions. So as we jump into this first video, I thought it's quite rudimentary that we cover the CIA Triad, and everything around it, what it does, and what are the main sort of focus points around how do we secure businesses, how do we secure assets, how do we secure people across the business. And this obviously is the first form where you're having these discussions with maybe certain business units. It may be an insurance firm, or it may be investment management organization, and you're really talking to people who are not tech savvy, who are not security focused, who wouldn't in the slightest idea have any concepts or understanding of these fundamentals. You can pull this up, you can dissect the CIA triad, and you go down into this in content where it resonates, where people understand or start to begin to form an understanding of their own in terms of the three core elements, and we'll get to them in just a second. So let's sort of begin things off with confidentiality. So confidentiality, you guessed it, is let me just write that before I can continue. It's very difficult to think and write and talk at the same time. So confidentiality is the first component here on the C. This is the C component of the CIA triad. And the C is basically, restricting access, and it's everything to do with beginning to understand how do we begin to restrict access. First, we need to understand, do we have some sort of governance structure in place? What's our maybe design principles, right? Some organizations have a zero trust model, zero trust. Other ones have maybe an attack surface reduction model. Other ones have secure defaults. These are all forms of maybe methodologies of secure design principles. When we talk about restricting access, the main sort of focus here is least privilege. And again, very similar to zero trust, very similar to attack surface management, attack surface reduction. It's about reducing the risk exposure across the environment, and least privilege is an element, or it is a form of us of going about that, right? So least privilege just basically says, hold up a second, does Jill or does Mary or does this business unit require any more privileges than they need to do? So this is basically giving them the bare access or the bare minimum in order to do the job function, right? And no more. And so is the same the true, right? So is a lot of this true in the forms of the organization, right? There should be no person in the organization that requires full access to everything and anything, and it is the quickest way to put security at a high risk. So just be mindful of that. So anytime we talk about confidentiality, just think in terms of restricting access. What is our restriction of access? And it's not canning access across people and making things very difficult for them to do their job. It's about auditing that process. And, if a certain permission is needed, then sure, you can go around and do a risk matrix or a risk analysis and form the risk management from there. But obviously understanding the risk exposure with that. So when we start talking about confidentiality, restricting access is that main sort of focal point. The other sort of area when we start talking about that is encryption, right? There's an element or a form of encryption, and making sure that we've got the right access controls in place, security groups, security policies, the posture itself across the organization. And when we talk about encryption, two forms come to play. We've got at rest. So the data, once the data is sent and received, it may be on disk or on file storage encryption, maybe it's hard drive, and maybe BIOS security, BIOS encryption, all those sort of things on the physical state. And then we've got transit as well. So once we start putting in solutions like VPNs or remote working arrangements for staff, and for obviously key business components or key business areas of the organization, as the data starts to traverse the network, there's going to be an element of encryption along with it, right? And we'll start talking a little bit about, symmetric encryption, and then we've got asymmetric encryption. Both of these forms, I'm not going to cover these off right now. We'll create some subsequent videos that we're going to discuss these. Basically, these are ways of just managing or supporting the keys in that process. So we'll talk about the public key infrastructure. We'll talk about how the data gets encrypted, de-encrypted using those forms of encryption. One form uses one key to encrypt and decrypt the data, which is handy. The other form uses multiple keys, obviously another secure by design model. We'll cover them at a later video. So we've got restricting access, we've got encryption, and then there's another little area as well that I'll just maybe draw over here, and that's protocols. And when we start talking about protocols, there's obviously a bunch of protocols across our TCP/IP stack, through network services, through system services, things that are very common that you may have seen. HTTP doesn't use encryption. We've also got SMTP traffic, so things like mail services. So should you be on a physical component on a network, very quickly we can start to sniff these services out. FTP is very common and still very widely used by a lot of developers. You can get a lot of the data because the data is unencrypted. So auditing that process and understanding why does a certain developer or certain team still use FTP in that moment, or why they're still using HTTP to access the admin console of the VMware vCenter, and is that restricted in a form of access control, security groups, things like that. So we can start peel back through basically all these forms, right? So when we start talking about confidentiality, again, it is the pinnacle point across one, restricting our access, across encryption as well, and then protocols. So they're the three little key areas across confidentiality. The next component over here is our integrity. And everything to do with integrity is the validity state, right? So it very simple in terms of do we trust the integrity of this system, of this application, of this piece of software that we're installing? And I'll give you, maybe we can sort of work through a prime sort of case study around this, and I think this will be a lot of fun. So let's take Jimbo here, and Jimbo is our #1 sales director at company X, right? So we work for a prominent organization, and we've come in to do a security project of some sort, or a transformation project. And he works at company X, and this is company X that's employed us. And now we're maybe doing an audit, or maybe doing some sort of design, or strategy, or whatever we're doing with this organization. And this is just figuratively speaking, and easy for me to maybe articulate this piece of this key area around integrity. So Jimbo requires, now this organization may have a process to download software or install applications. And if they do, that's fantastic. For many organizations, they don't. And this is where the integrity piece becomes quite challenging. And I'm just going to underline it because now we're talking about the integrity component of the CIA Triad. So anytime we start talking about integrity, it's basically, is this data tamper-proof, or has it been altered, or has been tampered in a form other than what it's intended to do? So let's maybe peel this back a bit more further. So Jimbo here is our traveling salesman of the organization. As many organizations now, we work remote. It's a form of obviously remote working. Maybe he's at a meeting at a customer site. Whether we do or don't have the appropriate VPNs and configurations and network services that have been set up like that, let's say that Jimbo requires to download a piece of software. So he works at company X, which is fine, and he's required to download software X. And then you can pick your vendor of preferred choice, right? There's many vendors out there that we need to download, applications for, maybe a co-sharing, or a co-working like collaboration tool set. It may be a video service. It may be a downloading, uploading files or downloading files. It's an application of state that he needs to download. How do we trust the integrity of that vendor is basically what this integrity component means, right? And that's taking it another step. It's basically, how do we know that the vendor, one, hasn't been altered with, or the application itself is safe to download and obviously execute and install, right? And it all comes down to this piece of magic, which we call hash file verification. Now, with hash file verification, before I sort of maybe jump into that, let's maybe sort of backtrack at a step. So what's the point of, I guess, installing software with a malicious intention, right? And that is obviously a form of exfiltrating data out. So taking data outside of an organization. And this happens in many forms. And a very common example of this is through rootkits. Now, if we start talking about rootkit development, which we will probably do in a bit of a later video, but right now, when we start talking about rootkits, basically rootkits operate at the kernel level of the operating system. So anytime a machine boots up, it looks at the initial hard drive, and then it begins its loading sequence or its loading profile from there to obviously, load the drivers, and basically begin, the startup of the operating system. So in this particular example, what would happen is where rootkits would take over the MBR file, so the master boot record, which is the way the machine sort of operates. The rootkits themselves basically replace the MBR with their own states. And this is before the booting process, meaning that once that MBR has been in an altered state, you can pretty much do anything you want on that machine. So in this particular example, when we start talking about rootkits, we can start to do a bunch of things. We can hide files. We can alter registry information. Reg info. We can do services, so we can alter and obviously hide processes along with files, which is very common. Right, and these are forms of obviously in coordination with exfilling data. So to install a rootkit, you want to have some sort of malicious intent, and then from there we want to take the data out. So forms of exfil can also be through covert channels. These are very forms of taking protocols like ICMP, DNS, your web traffic, your HTTP or HTTPS, and we can use those services to basically abuse those protocols, right? We can exfil data out of ICMP. We can exfiltrate out of common DNS entries, DNS services, things like that. And obviously, we can take it a step further and use other tool sets, which are quite common, which is Netcat is one, a very handy, nifty tool to communicate and understand what's running on that machine, but also to communicate as well. You can also send messages. It's a really amazing tool. And the other form is CryptCat, and that is the encrypted version of NCAT. Now, should the firewall be doing any sort of file inspection or application content awareness, the actual payload or the encrypted payload. So with CryptCat, it adds an encrypted layer to the payload. So as the data is going back and forth, the application firewall basically just sees it as normal services, or it may be doing something normal. It's not going to inspect it, or if it is doing inspection, it's encrypted. So, it makes the firewall a little bit harder to sort of detect or look into that payload itself. And the main form of this is obviously now moving into phishing, right? So anytime we do rootkits or exfil, it is a form of phish, and one of the easiest ways to cause serious havoc across organizations. And for many organizations, this is one of the easiest ways to get initial access or even do further damage when we start talking about exfilling data, but then obviously causing serious implications across the organization. So what are ways of validating, or how do we verify that these files that we've installed are actually safe? Well, there's 3 steps, right? So the first step is obviously download the file from the trusted source. So make sure that when you go to the vendor's profile, the vendor's page, it is the actual website of the vendor. It's not a duplicated state, or the attacker's done some sort of farming techniques to mess up the DNS records through DNS poisoning, and then you've gone to the attacker's, fake XYZ, .com, when the intended state was, abc.com of the website, right? So there's ways to validate that. You can maybe check the connection through an out of bands connection. You can maybe go to another machine if you've got another device, connect to another connection state, and then validate that the website is correct. Now we can take that a step further as well. And then while we've gone to the actual trusted site and we've downloaded that, the .exe if we're using Windows, or a .dmg if it's maybe, a Mac machine, or whatever thing that we're downloading, what we can then do is verify the hash. Now, this is where we're going to hash file verification, right? So hash verification is basically validating that this software vendor that we've gone to has now actually now let's maybe pull it back a bit. So we generate the hash on that downloaded file, so that the vendor itself may be generating, may say, okay, well, our file that we're downloading, if this is our file X, and this is an exe if we're using for Windows or whatever it is, and then that vendor will now say, well, this file has a hash version of ABC 1, 2, 3 in a very layman's terms. Now, usually this is a 128-bit string, so it's just usually a string value of just basically just text. So it's a 128-bit piece of value. Now, from there, it's obviously one way, right? So it's easy to take a file and run it through an algorithm and then basically spitting out a value. That's all it's intended to do. So the concept is that this company then creates a software that generates a hash, right? In this case, the hash is ABC123. From there, we would download it and we would run it against the hash algorithm. So let's say maybe this is an MD5 hash or a SHA hash. We can take those hashes and then we can run it against, our hash version, and then say, well, do we then spit out the same hash, which is ABC123, or is this now ABB, 21X, for example? And then that's a different state. So if they are the same that we generate, so if the same one over here is ABC123, then that validates, yes, the application or this exe file that we're downloading has integrity, it's valid. We are getting the same hash file verification in that process, right? So in those cases, you can do that. And there's multiple ways to do this with tool sets. So if we look at Windows, Windows has, certutil. In the command line, you can run certutil, you can run it through PowerShell. These are all sort of commands you can look up. Hash verification for Windows. You can also do it for Mac. Mac has its own sort of MD5. You can just basically, for certutil, you can just, I think the actual syntax is certutil tac hash file. And then you obviously put the file there, whatever the file is. And then I think you just specify the actual, the version, like the MD5 hash, or if it's a SHA hash, whatever SHA version it is. And then it will actually spit out the actual verification code. You then match that verification hash file with the actual vendor's hash as well. And then you know that that has not been altered, or it is the actual error checking correct of that code. So basically, anytime we're doing hash file verification, we are doing a form of making sure that it is unauthorized access. Again, tying into our first point of restricted access, making sure that we really dive down into who has access, why do they need it, and then obviously having a very solid point as to why certain people require this access. Now, the last form here is availability, right? So should availability, let's write that out. So any form of availability is basically just ensuring that our assets is available for consumption, right? So if we're a service provider and we're providing a service to our customers, then we've got, our 99 point, our 7 nines, or whatever 999% of uptime. If we are providing an element of, access to other customers through a portal page, for example, or, we're a sales-driven organization, it may be another sales page or a superannuation page. If these pages go unavailable for 3 days, that can cause severe business impacts, right? So making sure that our assets, our infrastructure, our assets, our technology state has the availability that it needs. It meets our customer demands. So I'm just going to say, 1 is availability, and availability. 2 is customer demands. right? And then we can take that further. So how do we ensure the availability, right? So ensuring availability, well, there's a couple of ways to do that, right? So the first part is, again, restricting our access. So not giving access to willy-nilly just to anyone. There's obviously a very valid point as to who and why do they have that access, and identifying those parameters. So you may have an asset inventory of who has certain privileges. The other form is through security controls, right? And these are forms of technical controls. We may have, DLP in place. We may have, the appropriate IDS or IPS services in place and that are in line with our, our correct infrastructure, and they're doing the right thing. And we'll talk about, the network hosts. So we've got NIDs and NIPs. So network intrusion prevention, host-based intrusion prevention. And then we've obviously got, endpoint detection. We've also got a form of maybe SIEM monitoring. We've got a proper, maybe a SOC team that are actually doing those things correctly. It's been monitored. And then there's actual proper triaging and things as well that are happening across that state. And the final element is failover. And that's tying it all together, right? So there's redundancy across, things like power, right? If something trips out, we've got redundancy, we've got failover. Maybe if it's cooling, electricity, it could be network, right? I've seen in many cases where certain WAN connections not being serviced correctly, where they're really limiting the failover across certain protocols, whether it's EIGRP. There's things that we can have that are in place. If it is network based, if we're providing that sort of network, make sure that the network services, the protocols themselves have failover as well, redundancy across technology, but then also our internal assets as well. So it could be hard drives, so hardware, storage, things like that across the infrastructure. So they're the three sort of key elements around our CIA model. That was the availability of the CIA Triad. Let me just zoom in there and just undo that one really quickly. That was our A for availability. So they're the three core elements. We have confidentiality, integrity, and availability. I hope you found this video useful, and I'll see you in the next video.